actually, we are going to continue where we left on the supply chain risk. Last time, what we did was we had taken the definition of a supply chain risk and also dealt with extensively all the risks that can arise in the supply chain, resource related risks, institution risks, and risks in the delivery service mechanisms. I have given lots of examples to give the risk. Why is it important to list all the risks that happen or that influence the supply chain? So this is because unless you diagnose the fault, you cannot rectify it. So it's very important that you know what are all the risks, that then you can try to mitigate the risks. So what we are going to do today is about the risk mitigation strategies. So the community risk is one of the biggest risks, particularly in emerging markets like in India. And I'll take one example, like what is called the Tata Singur case, where the Tatas had an automobile plant, which is for the Nano, which is a 1 lakh car, which is a very popular car, and that has been in West Bengal, in a place called Singur, and they have to move out, and that was because of the community risk. So such things like that happen several times in several cases, where we have seen last time the infrastructure like roads, ports, buildings, and so on, they take a lot of time. That's because of land acquisition and other problems. So land belongs to somebody who is either farmer or somebody, and then he doesn't want to sell it, because if he waits, the prices, the real estate prices will go up. So for whatever reason, people don't want to sell, and you are going against his freedom of speech, freedom of action, and so on. So what we need to look at, or how do you mitigate that risk kind of thing. It's a very, very special case. That's why I have separated this from the rest of the lecture. That's because community risk lead to what is called wicked problem, which are very difficult to solve. It has to be solved only through negotiations and so on. And the second thing is risk propagates and amplifies. So we have to take an engineering approach when you are trying to create a resilient supply chain. What is a resilient supply chain? Your system should be able to function in spite of the faults that occur inside the system, in spite of the failures. If you take a computer, if you have a dual processor, then if one processor fails, the other works. This is called triple modular redundancy and other kinds of things. And if one sensor fails in a thermocouple sensor fails in a boiler, then still, because there is an alternate way of measurement of the temperature, still it functions. So in engineering systems, people are used to, there is nothing, no engineering system is failure free. So there is a maintenance, repair and operations always trying to do once a failure happens. So we should borrow some of these concepts of engineering, maintenance and repair into supply chain and see what we can do here. That's how we create resilient supply chains. And finally, we conclude this particular chapter. So let's look at what is the Tata Singur case. Tata Motors is the largest passenger and commercial vehicle manufacturer of India, a part of Tata Group of companies, and it holds 96 operating companies in 7 business sectors. The Tatas are there. It's a very famous company in India. In 2003, Ratan Tata, chairman Tata Group, embarked on a vision to build a Nano, what is called a people's car. Why? He says, I observed families riding on two-wheelers, which is very common in India. The father driving the scooter, his young kid standing in front of him, his wife seated behind him, holding the little baby. It led me to wonder whether one could conceive of a safe, affordable, all-weather form of transportation for such a family. Well, when you are using a scooter or it's a two-wheeler, then if it rains, then you cannot travel. So, but on the other hand, he wanted to create for almost the same price, which is safe, affordable, and all-weather form of transportation for such a family which cannot afford the usual cars that we have. So, this is where his vision was to have what is called a 1 lakh car. 1 lakh is 100,000 rupees, which is equivalent today to less than $2,000. So, several governments, when Tatas had mooted this idea, then several state governments, they wanted Tatas to establish the plants, and they were offering lot of subs. The state of West Bengal in Calcutta, it offered 997 acres of land. 647 was for the Nano plant, 290 acres for ancillary units, and 60 acres for Industrial Development Corporation. So, the total is approximately 1,000 acres. And the farmers started agitations with the support of the opposition party, because this is a fertile land where the farmers were using produce, and it is the produce that they are using for their support and livelihood. So, the farmers started agitation, and the opposition parties, they helped the farmers to agitate more. And the state government supported by the High Court ruling. So, it all went to the High Court, and the High Court ruled that in January 2008 that the land has been legally acquired for public interest through Land Acquisition Act, and urged all farmers to accept the compensation package offered by the state. Now, here what happens in India is that the state owns the land, and it acquires from the farmers, and it gives it to the industry. Now, farmers are saying the industrialists are making so much of profit, so why not they pay more? So, there is a compensation package and an issue that's involved. And Tata started building the plant along with the partners. So, the issue here is there is a vision to have a low-cost car for affordable by lower middle class families, and the state government wanted to have that plant so it can create jobs, it will boost the employment potential and the economics of the state. So, they are given approximately 1,000 canvas land from taking it away from the farmers. And since it is all legal, and the High Court also is ruled in favor of the Tatas and this particular project, then Tata started building the plant. So, the supply chain was meticulously planned, because it's a 1 lakh car, it's a low cost car. So, whenever there is low cost, you have to minimize the cost at every place. So, that's where meticulously planned, co-locating all the vendors so that the transport costs are minimal, auxiliary units and proximity of the plant, and what is called the Durgapur Highway in Kolkata in West Bengal. And it is closer to the port, so the transportation is also cheaper. The land acquisition procedure and short-term arrests were not seriously taken by the Tatas. Well, so, and they relied on the government of West Bengal, which also took the judiciary into this one to look into the land acquisition procedures, and they started building the plants. So, they started construction of the plant and installation of the machines to commence operations at the earliest. Their partners also built. So, basically there is something like rupees 15,000 crores have been spent in making this project planning. So, I am going through this with to the whole procedure. That's because what went wrong, and finally all of us know that Tatas have to leave this, and the project came to a grinding halt, and Tatas have moved to another state before Nano was rolled out. So, when everything was taken, when Tatas think that they have followed all the procedures meticulously, followed the book, what went wrong? The Nano was supposed to be launched in a month. Then Tatas leave Singur because the agitations of the farmers did not stop. The spate of agitations intensified to such an extent that the inventory in the Nano plant was damaged, factory gates were not allowed to be opened, and employees of the Nano plant were assaulted. So there were people sitting, opposition party members and farmers sitting on hunger strike. And they were sitting in front of the gate. They are not allowing everybody. If anybody wants to enter the plant, then they were assaulting them. So because of this kind of situation, several other state governments offer sites. So you should see the opportunity. Other governments, state governments wanted to take this opportunity, worried about the prolonged agitation against the project and the security of its employees. Tata's finally pulled out of Singapore to the state of Gujarat. Now Gujarat state offered them enough incentives, and so they basically went out of this one. So what does the story tell us? The story is that when you wanted to land, there are two kinds. When you are in the supply chain case, there are two things. One is the project planning. What is project planning? You have to acquire land, build your facilities, and bring your machinery and put everything in place. That's the first project planning. The second thing is, once you have installed all the machineries, then you should start your production and start the supply chain planning. Now, there are two different aspects to this. Now, the people that the industries make is they will have the same CEO for both the operations. In other words, for a project planning, which involves land acquisition, building construction, acquisition of machinery, and so on, and dealing with the locals, any problems and so on, these are all the project planning problems. Whereas, once the machinery is set, the supply chain planning is all professional. So a CEO for supply chain planning, can he handle the locals? Can he speak the local language? Can he talk to the government? Can he talk to the judiciary? Can he talk to the opposition parties? Can he negotiate with the opposition members and so on, and try to arrive at a decision? The answer is a big no. The capabilities that are needed for running a smooth supply chain factory and the domain knowledge that is required there is much different from running a project which is particularly highly sensitive to the locals. And he should know the local language, he should know the local politicians, he should know the local people, and so on. So basically, I try and speak the local language to convince people. But that's where the whole thing went wrong. None of them benefited. Tata certainly did not benefit because they had to relocate the entire plant, which cost them a lot of money. And it has also delayed. They wanted to launch the Nano in a month, but it has got delayed. And the government of West Bengal also did not benefit, as it could neither convince the opposition party nor the Tatas to wait until the talks materialize. And it suffered a lot of ill will because a lot of companies which basically wanted to establish, along with once the Nano is successful, the New York Times headline says the world is waiting for Nano to come out. Then once this has happened, and Tatas have a lot of reputation, and they have industries all over India, and so if they cannot do it, who can do it? So that's the kind of logic that has given a lot of ill will to the state of West Bengal. And the farmers obviously did not benefit because those who protested to get their land back did not get till date, and their land abandoned after Tatas pulled away. So basically, once Tatas pulled away, the land becomes worthless. That's because nobody wants that land, and whatever has been transferred to Tatas, it has not been transferred back to the farmers. So the project did not serve the purpose intended to. So what is this kind of questions that arise? Did this magnanimous project of global importance end up in a fiasco because of the negligence and underestimation of minute factors? Is that this one? The second factor is several MNCs who wanted to open shops in West Bengal have either postponed or abandoned their plans. lack of talent and negotiation skills is responsible for this debate? Is that the problem? So, such problems in society, where several partners, government on one side, the industry on another side, the people on the third side, opposition parties on the fourth side, and on the fifth side, other states who are trying to lure Tatas into this. So, there are 5 or 6 partners who are basically trying to get the problem solved in their own way. So, such problems are called wicked problems. It's a phrase used in social planning to describe problems of this type, which are difficult or impossible to solve. They are difficult or impossible to solve because of incomplete, contradictory and changing requirements that are often difficult to recognize. In other words, here there are 5 or 6 players. They are dominant players, and everyone is right. The farmers are saying, look, this is my land which my grandfather has given, and if you take it away, I don't have any food. If you are giving me, then you give me a proper compensation before you take it. Then the government is saying, look, if it Tatas come here, the others also will come. The economy of the state will improve, will provide jobs and so on. It is good for the state of West Bengal. Well, the Tatas are saying, look, there are several offers, but we came here because of the port of Calcutta, and also since you are offering the land at a convenient price for us, and we came along with all our people. So, and it is a 1 lakh car, so we cannot afford to pay much more. Well, the opposition party is saying, look, you have bundled this, and we are a party, we are on the side of the poor farmers, we want to support them. And other states are saying, look, we will give you a lot of jobs, why don't you come here? So, everybody is right in this world. So, how do you solve such problems? Because of complex interdependencies, the effort to solve one aspect of a wicked problem may reveal or create other problems. So, if so these are called wicked problems. How do you solve wicked problems? Let's look at social complexity. Social complexity is a function of the number and diversity of players involved in a project with strong and accurate opinions of them. So, I mentioned in the Tata Singer case, there are 5 or 6 partners, each having their own opinions, and each is right. And the conflicting views among various stakeholders lead to no acceptable solution, causing projects not to take off. So, here there are conflict. Farmers want more money, Tatas cannot give, they want it immediately. The state of West Bengal want to give the compensation as agreed, and the opposition party wants to bring down the ruling party. Everybody is right in their own way, they are playing their cards. So, but is it possible to negotiate in such a case? The problems in which social complexity is coupled with fragmentation of decision making is called wicked problems. Let's look at characteristics of wicked problems. The problem involves many stakeholders with different values and priorities. The problem is difficult to come to grips with and changes with every attempt to address it. Now, I don't know whether the state of West Bengal or the Tatas recognize that it was a wicked problem and it was a failure of negotiation skills. Because it's very difficult to say. They think that, this is a straightforward problem, somebody didn't agree, so we moved out and so on. But on the other hand, there is a community loss here. In other words, for the years Tatas have spent, and Tatas have lost money, everybody has lost money without any gains here. So, this is a loss of the country. So, this kind of things should not be happen, and so on. And each time you change, at one point it is between Tatas and farmers, another time it is between opposition and the state government, at another time it is in the court between the opposition, the state government and Tatas and so on. And another point, it is West Bengal versus other states. So the problem starts shifting. So there is no right answer to the problem. Yeah, everybody is right. So every implementable solution to the problem has consequences. Yes. It's also easy to see in this. There is no definitive formulation of the problem. In other words, you cannot solve this as an optimization problem. They are called hard-or problems. And every problem is essentially unique, and the problem has no precedence. In other words, if it happens, of course, if you say Land Acquisition Act, the land is different in Andhra Pradesh to, it is different in Tamil Nadu, it is different in some other state. So, but still, the land may be land, but the problem becomes unique at every place. At one point, it could be for a port, at another place, it could be for some other industry, at some other point, it is for a plane, for a power plant and so on. So, one has to treat each of them as a unique, this one. So, how do you solve those problems? So, traditional way of solving such problems, decision-making problems, is what is called operations research. Use a lot of optimization, modeling, simulation, and so on. But what we hear are soft or, this is the term that the people use, that is soft operations research employs predominantly qualitative, rational, interpretative, and structured techniques to interpret, define, and explore various perspectives of the wicked problems under scrutiny. So, basically there should be somebody who looks at the entire problem. And is it then the most important thing that one has to look at here is it important to solve this problem and find a solution? Should Tatas really get this land? Well, if it is in the interest of the society, interest of the government, it's the interest of the economy, and if one decides that since they have already started this, it is good for the country, good for the people and so on, then one should try and negotiate for this. What are the negotiations? It's called dialogue mapping. Dialogue mapping is a process that allows diverse groups to generate coherence around wicked problems. There are several ways of solving these wicked problems. For example, a government can bring a law saying that it is allotted and any actions that anybody does is illegal and they are liable for prosecution. That's an authoritative way of solving it. So, well, that is also done in several countries and several places, and it is possible to do that. But there is another way of doing is called collaborative networking. In other words, you talk to people and have a dialogue and convince them it's a project that has to be approved. And you find out who gets what and negotiate, and each fellow goes beyond. In this particular case, the farmers, instead of getting X amount for their land per acre, they get 0.9 X amount. So the farmers go back and they say, instead of Tatas say, instead of paying something, Tatas may say that they will give jobs to some of the people in the farmers' sons, daughters who are employable in this. And state government say it may give some money to Tatas to compensate for all this. So each one retaliates, goes back, and then renegotiation starts. This is a collaborative way of decision making. Then problem is solvable. The method in a meeting, facilitator paraphrases, captures all the views in a hypertext diagram on the screen. This is called a dialogue map. And the result is dialogue map does not provide any solution. It facilitates common understanding of the problem by all stakeholders and helps them arrive at a consensus. So when somebody sees this is good thing to be done, and it has to be done, and let's negotiate what everybody gets it, and it's in the interest of the people of this country and so on. And the effect is the decision will have to be taken by all the stakeholders involved in the process, and they will develop a sense of ownership and responsibility for the solution, and all of them will respect and adhere to it. So, whatever solution is obtained from dialogue mapping, this is a tool that to tame the wicked problems. It's basically, you are solving in a collaborative networking fashion these problems. I mean, there are several problems of this kind, and I don't know whether Tata's followed this dialogue mapping, have a meeting. Every time it ended up with in a chaotic fashion. So, there are a lot of wicked problems that are there. One are environmental degradation. There is this terrorism, I mean, particularly jihad, the terrorism, they think they are saving the world, they are saving their religion, they are saving their people. And poverty, global warming, long-term social planning, organizational planning, there are several wicked problems which are solvable in this, and so on. So, they suffice it to say that there are lots of problems, particularly the institutions face, that the community risk, particularly coming out of land, water, for example, installing nuclear power plants in a place. I mean, the government say, we want a nuclear power plant because we want a green power. That to this one, the coal power is not good, we don't have enough coal, and so on. And the people say, if there is a blast, then we will get affected. So there are several issues that come in here, and either the government has to come in an authoritative way, or it has to convince people that they will take all the precautions so that the nuclear disaster won't happen. Even if it happens, they will mitigate that risk. And they, in an understandable way to all the people, they should put all this on a piece of paper and circulate it or explain it to people. So that's what happens in the community problems. Another important problem that is facing the governments today is the cyber security. As we have seen earlier, that supply chains are highly connected. They are connected through all the goods, information, and financial flows are connected, and the internet plays a very big role in connecting the information and the finances and so on. But as we also saw, the connectedness also brings risks, and one of the risks that have been discovered in the last 2 years is what is called cyber security. So what are cyber risks? Disruptions to supply chain flows caused by IT defects or damage. Now, what happens if your power network fails? Well, everything comes to a grinding halt. You may have a battery backup, but the backup only works for some time. But what happens if your IT system goes? You don't have any backups. I mean, you can have backups, your battery for your own computers and so on. What about your network? So it becomes unoperational. So the flows, this disruption to the flows, supply chain flows by IT, it's called cyber risk. And this cyber risk, if it happens due to a natural calamity, that's a different thing. But it is happening as cyber attacks. In other words, somebody is doing this intentionally. This is like a war. So exposure to malicious actors through remote exploitation of IT weaknesses. In other words, somebody gets into your computer, he steals all the files, all your passwords and so on. Exposure to malicious actors through installation of corrupted or counterfeit ITs. In other words, the software that is there in the computer is counterfeit or corrupted. So it is corrupted with a virus, and the virus will send out all your password, all your information. Whatever you type, it is transmitted to somebody else. So they know your username and password to your bank account, and they can basically steal your money. So the cyber attack, with all the innovations that we discussed earlier, the cyber attack is a big this one. Now, cyber attack by people is different. But what is happening? Cyber attack by people, the terrorists and thieves, is a different issue. But now, the recent cyber attacks are by the governments. And that's the problem that creates another thing. The hacktivist groups targeted businesses in recent cyber attacks by hacking and defacing websites of businesses and government entities for purposes of political and policy protest. Well, this is one thing, they enter into your website and change all your biodata and other things, your policies, so that you get a bad name. And hacktivists also conducted what is called distributed denial of service attacks. That is, they basically a network resource like a bank or a credit card payment gateways are connected to the internet or unavailable to the users. So they make a particular server inactive. But that's more problem is here is there is a software called a computer worm called Stuxnet. In June 2010, it was discovered attack of nuclear facilities of Iran. The Iran nuclear power plant was disabled. It did not function in June 2010. Why? It's because of the Stuxnet computer worm. What is this worm? Stuxnet spreads indiscriminately via Microsoft Windows and spies and subverts Siemens supervisory control and data acquisition system. Now, the supervisory control and data acquisition system, or SCADA, is a very important thing in industries. Any industry has got what are called PLCs, programmable logic controllers, and all these PLCs are connected to a main computer, and they're all used for data acquisition as well as control. In other words, if you have a factory floor, you have all numerical machines, controlled machines. Each numerical control machine is controlled by a PLC. All the PLCs are controlled by another PLC, which basically controls whatever flows through the machine shop. And now what happens is if that PLC is affected, in other words, the Stuxnet infects the PLCs by subverting step 7 software applications that are used to reprogram these devices. So, if the control system is affected, becomes defective, then there will be a particular problem, unless you have a redundant control system. So, but usually you don't have a redundant control system. Control system is the one that is supposed to take care of all the factors, both during faulty times and during normal times. But here, these people are affecting, and these are Siemens products, and Siemens supervisory control and data acquisition systems were affected. This was recent cyber attacks that made history. Now, what happens here? I mean, the Stuxnet is supposed to have been done by some governments to affect the Iranian nuclear power plants. So, this is becoming like cyber warfare between countries. By disabling your aircrafts, by disabling your nuclear power plants, by disabling your power plant operations and so on, because these are all standardized control equipment which are accessible. And if they are basically, since they are accessible, if they are pirated and you are basically worms are basically attack those facilities, then you have a problem. So, the world is entering into a phase where the risk attacks are increasing by the communities, by the governments, attacking the finances, attacking the information infrastructure and the power infrastructure, and all that is becoming a big issue nowadays. So, what we have did so far is to consider all the risks. Now, let us look at how risks propagate this one. In a globalized world, the risk for the supply chain could come from three other very important factors which are often ignored: connectedness on a global scale, large scale concentration for competitive efficiency, and lack of governance for fast response. Let's look at a particular diagram. Supposing there is a supplier from you are sourcing, and there is a disruption in the supplier. In other words, there is a fire in his factory or done, so on. Now what do? You are sourcing from that supplier, and the supplier for some reason becomes ineffective. So sometimes you keep inventory, okay, or sometimes you don't keep inventory. If you are a lean, JIT and so on, then you may not keep inventory. So if you don't have inventory, you try to procure from the market. In other words, you go onto the web, you go to an open exchange and try to buy it, or buy it from some other place. Well, most probably you may get it if it is not a very critical component, which is specially made for you. If it is a generalized component like a processor or a power supply kind of thing, you can always be able to access it, but sometimes you may not be able to get it. So what we are trying to do here is what a decision flow diagram, how once a flow or once a disruption occurs. If you map like this, then you know how to mitigate those kind of risks. So how the risk flows inside your system. So we have said if you have inventory, then you don't have any problem. You solved the problem. 0.8 with probability 0.8, you have an inventory. You have a problem if you don't have an inventory and you can procure from the market, then you procure it, then you are done. But supposing you don't have the inventory and you cannot procure from the market, then customer unwilling to accept late delivery. You go and call the customer saying that, look, I have a supplier failure. So because my production has stopped, because I am trying to access from the market, I couldn't get it. So can I deliver after 1 month? Well, the customer is willing to accept the delivery, then you are done. Then you can procure. You have time. You are basically buying time when customer is willing to accept. A customer unwilling to accept the delivery, he will try to procure from some other place and so on. If the customer is willing to take the delivery, idle manufacturing cap not sold, suppliers not postponed. There are two, this one. What happens is, if supplier is willing to accept late delivery, then you are okay as far as this particular supply is concerned. But your manufacturing capacity, you have scheduled the production of this particular product on your manufacturer line, thinking that everything goes okay. Your supply chain planning, ERP systems will tell you, you have this particular product is to be made during this particular time, 14th, 15th of this month. What do you do with that capacity? So you try to idle manufacturing capacity, you can sold, but then you never usually have one supplier. If one supplier there are several components, but for example, in auto plants, there are 3,000 other suppliers who are supplying, and basically for the other suppliers, either if you ask them, you also postpone because this component I am not getting, and sometimes they agree, sometimes they don't agree. So you have several cases that is coming here. Idle manufacturing capacity sold, supply is postponed. That's an ideal situation. Idle manufacturing capacity sold, supply is not postponed. That's because you basically, that's a very big chance. So you have basically not postponed, so you have to maintain the inventory of these supplies. Idle manufacturing cap not sold and supplies postponed. This is basically is another case. So your capacity gets wasted away and your supplies, you have to maintain the supplies and so on. And here, if the customer is willing to accept late delivery, then idle manufacturing capacity sold, idle manufacturing supply not cancelled, idle manufacturing cap sold, supplies cancelled, idle manufacturing capacity not sold, supplies not cancelled. So you have 4 cases here: idle manufacturing capacity sold, and supply is cancelled, idle manufacturing capacity sold, supply is not cancelled, and so on. So basically what happens here is when customer is willing to accept late delivery, then you get into all these problems because you have an idle capacity. So what I am going to try to is basically if you want to make a decision, how do you create a resilience here? One thing is you want to have inventory. Instead of going through all this idle capacity and all these problems, you can basically have a cost estimates of all these options. And you say, look, it is better I have the inventory, I need not have to stop. If I have a 15 days or 1 month inventory, then other things will take care of it. So that's one way of doing it. But on the other hand, if you want to have a lean mean system, and if I don't want to have inventory, then you want to procure for the market in case you have an alternate source which is there, then that's also fine. But if both don't work out, then you get into some kind of problems. So this basically, of course, you will have since your inventory, then when you have inventory, your idle manufacturing capacity can, and the suppliers, other suppliers cancellations, these issues won't arise in this particular case, in these two cases. In those two cases, you are using the existing capacity as well as other suppliers, but you get into these kind of problems only in the other two cases. So what does this diagram tell us? This diagram tells you the various factors that happens, and once you know the probabilities that and also the cost estimates, then you can decide whether you want to have inventory or you want to take a chance. Another popular thing that happens in terms of the supply chain risk is what is called the port shutdown or the manufacturer's response. Now, this happens very frequently. For example, the Los Angeles port, the laborers were on strike and the port was shut down. Okay, so once the port is shut down, then in other words, all the ships that are going there, they cannot be unloaded and they have to be diverted to some other place, or the shipments, they should not take shipment. Whatever goes through Panama Canal has to go through via Suez Canal. Supposing there is a strike on Panama Canal, then you will have a lot of problems. So if there is a port closure, can continue to supply the customer, then this additional can continue procurement, cannot continue procurement from the supply. These are the options here. And inventory, for example, customer inventory available, inventory not available, local alternative suppliers available, local alternate suppliers unavailable, customer unwilling to wait, customer willing to wait. So there is basically several this one that happens, cannot continue to supply to the customer, alternate routes unavailable. In other words, you can, when the port closure, you can still continue, but there is an additional transport cost. In other words, if it is say there is a shipping strike, you can go to another port and continue the procurement from the suppliers, and the inventory available, inventory not available. For each of these cases, you can still continue to supply. But supposing you cannot continue supply, then alternate routes are unavailable, alternate routes are available, additional cost of transportation, and so on, the cost of shutdown. So basically what I am saying here is that your manufacturing response depends on whether you can continue to supply to suppliers or you cannot continue to supply, depending on the additional this one here. And there is the cost of shutdown, cost of lost sales, cost of shifting production, cost of additional transportation in all these cases. So what I am saying here, really, if you map these diagrams, then it becomes easy for you to see where your fault points are. Now, how do you create a resilient supply chain based on all the knowledge that we gained here? There are many actors. Risk management need to be radically modified with changing role of governments in the economy and dismantling of state-owned monopolies. Public issues related to risk nowadays involve a variety of actors, including corporations, representatives of civil society, non-government organizations, and so on. So, all we are saying here is that we are having the issue of ecosystem, this one. But what is resilience? Resilience is the ability to resume and restore operations after a disruption. This is like what I am saying, that in engineering systems we are used to resilience. In other words, a system operates, you go and repair, it operates, or you have dual modular redundancy or triple modular redundancy. In spite of the failure, then the system still operates. So, is it possible to have resilience for this in the supply chains? Resilience can be achieved either through redundancy or through building flexibility into the supply chain. We have seen in the case of example of a supplier failure, if you have redundancy, that is basically if you have inventory or a dual supplier, then you could do it, but you can also build flexibility into the supply chain. Standard use of redundancy includes either excess capacity or use of safety stock of material and finished goods, or dual sourcing, or manufacturing in multiple sites. So, this is what we have seen in that example. You have melt safety stock and also a dual sourcing. You have another place where you can source it from. And inventory can give a company time to plan its recovery following a disruption. Indeed, many companies have increased inventories when preparing for a disruption. So, inventory can give a company time to plan. We have seen this in that supplier disruption example. And in terms of flexibility, to build flexibility in resilience, for resilience, companies must evolve many facets of supply chain design. So, developing ability to move production among plants, that's flexibility. In other words, you have two plants, one in Singapore, another in Eastern Europe. If there is a problem in Eastern Europe, move to Singapore. If there is if in normal times you do it in Eastern Europe. Use interchangeable and generic parts of many products and cross-train employees. In other words, you can basically interchangeable parts. It's not have to be standardized parts, but same power, it can be used, the power supply can be used, and the things are generic. Designing products and processes for maximum postponement, as many operations and decisions are possible in the supply chain. See, this postponement is one of the things. You postpone till the order finally comes. So, you design products so that you can postpone maximum of your things till the final order comes. Firms rely on global shipments should build decision support that can advise shifting delivery routes to different checkpoints if need, based on the information at border crossing. So, before you ship, you find out what is the situation at the border crossing, and you find out, instead of shifting to one location, you can shift it to another ship it to another port and then truck it from there. Shifting one mode of transportation such as air freight to backup routes by another mode. So, in turn, these steps may raise costs and affect production lead times and inventory levels. Well, suffice it to say that both flexibility as well as the redundancy, they cost money. There are the ways in which you can create a resilient supply chain. Now, but the point is, any resilience or any reliability into your supply chain, it is going to be costing money. So, you want to operate, you want your system to operate even in spite of some of the failures. So, if you want to do that, you have to spend more money and so on. So, the common global risk strategies are the following: 6 broad non-exclusive strategies for a government, corporation or individual are the following. The first option is seek to avoid the risk wherever possible. don't go to the place where there is risk. Second option is to mitigate the risk directly. Attempt to reduce the impact of likelihood of the risk, dual sourcing, keeping inventory or examples. Third option is uncertainty reduction through collaborative effects of sharing data, risk-related information, and in preparing supply chain, long-term contracts, and so on. And fourth option is to adopt risk by preparing for its occurrence. Well, this is like mandate that buildings should be flood prone, either elevate the structures and so on. So you know that you are preparing for the risk occurrence. The fifth option is transfer of risk by insuring to a third party. And the final and critical option involves accepting the residual risk. In other words, you know risk is possible, and the organization or individual is well aware of the potential impact and can hold resources or make other provisions to deal with the possible consequences. Well, either you ignore the risk, say whatever happens, happens, or you take it for this one, so I am prepared, I will spend this extra money to keep inventories, to do whatever with this one. So there is no other ways of doing it. You have to either have redundancy or flexibility, or the ways to get at this one. So what are the conclusions? You have to basically balance here your risk versus your resilience. So design of resilient supply chains is an important topic and should focus on specific vertical. So the conclusions that one gets are different for different verticals. For oil and gas, it's different from electronics. It is different for auto and so on. No supply chain strategy will eliminate risk, nor should it, because as the cost would be too high. This is like saying that no, humans should not get a disease. Well, you cannot make a human not get a disease. The managers can excel in identifying, quantifying, and preparing for the new realities of risk. So this is one of the things, because there is the unexpected risk and there is the expected risk. This is unexpected risk becomes a problem. This is like somebody who is normal getting a heart attack, then that is unexpected risk. But somebody who has a blood pressure and diabetes getting a heart attack is an expected risk. Determining whether greater resilience is worth extra cost is a part of the new management function. So the management need to decide whether they need the extra this one or they don't want the extra this. So basically this is between the cost you spend to create resilience and this what you suffer, the losses you make when the failure occurs. So which one is the balancing act is the one that is a part of the management function. So suffice it to say that the supply chains are getting leaner, and once they are getting leaner, what is happening in the supply chain literature is the global supply chains are basically more risk prone, and there are several partners who are creating the risk, from government, social groups to the ports to the companies and the terrorists, everybody. So, and the risk is becoming more soft oriented. In other words, it's that a community risk or cyber risk and so on, which are difficult to first to find out that there is a risk, and also later to mitigate this. So the supply chain risk is a very important topic that is attracting the attention of people nowadays. Thank you.